Study guide for the Chapter 8 geometry test. So this is what the Chapter 8 geometry test will look like. All right, I'm going to white out some stuff so we can have some space to show our work here. Square root of 64. Square root means what times itself equal. What times itself equals 64? The answer is 8. Number 2, square root of 3/7. You cannot have a fraction in the square root. That's the square root 3/7. So we're going to split it into the square root 3 over square root 7. But you cannot have a radical in the denominator. So we rationalize the denominator by multiplying by square root 7. We're going to get square root 21 over 7. Remember that when you have square root 7 times square root 7, you created a pair of 7s by doing that, and out pops a 7. Or you could think square root 7 times square root 7 is square root 49, and what times itself equal 49? 7. Okay? So number 2 is square root 21 over 7. Number 3. Number 3 is getting a little more complex, so we're going to go through the 4 questions that we ask ourselves in the right order. Question 1, will anything reduce? No, you cannot reduce the 4 and the 2 because the 2 is in a radical. Question 2, will a radical break down? No. Question 3, is there a fraction in the radical? No. Question 4, is there a radical in the denominator? Yes. So we're going to rationalize the denominator. This creates a pair of 2's. From the pair of 2's, out pops a 2. So it's now rational instead of irrational, having a square root. So on the top, we've got 4 square root 7 times square root 2 is square root 14. You multiply the names and you get a new name. Back to question 1, will anything reduce? Yes, the 4 and the 2 will reduce, and so we have 2 square root 14. Any questions on number 3? Okay. Number 4. Number 4, we have 3 square root 15,120. So we're going to break down the 15,120 and the product of its primes. We would have 7,560 when you divide by 2. Divided by 2 is 3,500, and 250 is 3,750, and 30 is 3,780. Divided by 2 is 1,500, 350, 1,850, and 40 is 1,890. Divided by 2 would be 945. Divided by 3 would be 315. Divided by 3 would be 105. Divided by 3 would be 35. Divided by 5 would be 7, and 7's prime, so we stop, and that's good because we were about out of room. So we're going to replace the 15,120 with the product of its primes, 2 times 2 times 2 times 2 times 3 times 3 times 3 times 5 times 7. Since it's square root, we circle sets of 2, so we have a set of 2 2's, a second set of 2 2's, a set of 2 3's, and that's all the sets of 2. We make a new radical. The 3 was already outside, so we leave it outside. From each set we circled, we bring a number outside. From that set of 2's, we bring out a single 2. From the second set of 2's, we bring out another 2. From that set of 3's, we bring out a 3. What did not get circled in a set goes back in. If there's more than one number on the outside, they get multiplied. 3 times 2 times 2 times 3 is 36. Square roots of, if there's more than one number on the inside, they get multiplied. And so we get 36 square roots of 105. 36 square roots of 105 for number 4. Any questions on that? Okay. Number 5, we have the altitude drawn to the hypotenuse of a right triangle. This is the altitude drawn to the hypotenuse of a right triangle. If the altitude is drawn to the hypotenuse of a right triangle, then the two smaller triangles created are similar to the whole big triangle, which creates the geometric mean concept. The altitude is the geometric mean between the two segments of the hypotenuse, and either leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. In other words, altitude is equal to square root of piece times piece, and leg is equal to square root of hypotenuse times closest piece. To name the similarity that is created, remember what we do is this. We said that angle A let me get things working here. We said that angle A of the whole big triangle and angle A of the little one on the left is the same angle. So if A is first here, it goes first there because it's the same angle. A is equal to A. D of the whole big triangle and D of the little one on the right is the same angle. So since the D was last here, the D goes last there. The B was 90 degrees on the whole big thing. The C's are the 90 degrees on the little one. Since B's in the middle, the 90's in the middle, then the 90 goes in the middle on the other two. Then all we have to do is find out what's left on the little left one. We've already got AC. The only thing left is B, and so we need our B in whatever position is left, which is last. On the one on the right, we've already got C and D. The only thing left is B, so we need the B in the position that's left, which is the first position. So we named the similarity with corresponding parts in order. If the altitude is drawn through the hypotenuse of a right triangle, then the two little triangles formed are similar to one another and similar to the whole big triangle. Based on the similarities and all the proportions that would come from it, we could say this. If the altitude is drawn to the hypotenuse of a right triangle, then the altitude x is the geometric mean between the two segments of the hypotenuse, meaning that x is equal to the square root of piece times piece. Either leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg, meaning that that leg y is equal to the square root of the hypotenuse and the closest piece 9. And the other leg z is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg, meaning that it's equal to the square root of the hypotenuse 25 and the piece closest to it 16. Now square root 9 is 3, and square root 6 is 4, and 3 times 4 is 12, so x equal 12. Square root 25 is 5, square root 9 is 3, 5 times 3 is 15. Just a second. Set my eraser in the wrong tray. Square root 25 is 5, square root 9 is 3, 5 times 3 is 15, so y is equal to 15. Square root 25 is 5, square root 16 is 4, 4 times 5 is 20, so z is equal to 20. So the altitude x is 12, the one leg y is 15, the other leg z is 20. Any questions on that? If the altitude is drawn to the hypotenuse of a right triangle, then the two smaller triangles formed are similar to one another and similar to the whole big triangle. Based on the proportions that come out of those theorems, we can say that the altitude x is the geometric mean between the two segments of the hypotenuse. Yeah, it didn't click. The altitude x is the geometric mean between the two segments of the hypotenuse, and either leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. Okay? We want the geometric mean between 8 and 9, 8 and 12, excuse me. We do want you to know that geometric mean is properly defined with a proportion as 8 over x equal x over 12. But after you cross multiply that proportion and get rid of the square with the square root, you end up with the square root of the product. So you end up with the square root of 8 times 12. Now 8 times 12 is 96. So we have square root 96, and we can break down that 96. 96 divided by 2 is 48 divided by 2 is 24 divided by 2 is 12 divided by 2 is 6 divided by 2 is 3. We're going to rewrite it as the product of those primes. 2 times 2 times 2 times, how many 2's are there? 5. We would circle pairs. We got a pair of 2's and another pair of 2's. We would rewrite our radical. From each set, you bring one out. So we bring out a 2 from the first set, and we bring out a 2 from the second set. What wasn't in a set goes back in. You multiply and get 4 square root 6. Or you could think, what is the largest perfect square factor 96? Let's talk about it that way one more time. So if we thought about the factors of 96, we could say, well, the factors of 96 are 1 times 96, 2 times 48, 4 times 24, 6 times 16, 8 times 12. And so we get the factors and we think, well, what is the largest perfect square factor? Well, 1's a perfect square. 1 squared is 1. 4's a perfect square. 2 squared is 4. 16's a perfect square. 4 squared is 16. The largest perfect square factor is 16. So we could think of this as square root 16 times square root 6. The square root 16 is 4, and so we would get 4 square root 6, which is what we got doing the prime factorization thing. So if we can mentally identify the largest perfect square factor and bring out its square root, then we can break down a radical a little bit faster, okay? All right. Numbers 10 through 12. We're looking for missing sides of right triangles. We know 2 out of 3 sides, so we're using the Pythagorean theorem. The one across from the right angle is called the hypotenuse, so that's our C. So we say C squared equal A squared plus B squared. It doesn't matter which leg you call A and B, but you do have to call the hypotenuse C. So the hypotenuse C, which is X squared, is equal to one leg 5 squared plus the other leg 13 squared. 12 squared. Got ahead of myself a little there, didn't I? So to solve, we're going to do the addition. We'll have x squared equal 25 plus 144. Now we're going to do the addition. X squared equal 169. We will undo the square with the square root. We want the positive square root only because we're talking about a distance, and so we get a 13. Any questions on number 10? Okay. Number 11, we know 2 sides of a right triangle. We're looking for the third side. We're going to use the Pythagorean theorem. It's important to identify the hypotenuse, the one across from the right angle, as being your C. And we use the formula C squared equal A squared plus B squared. So we take our C of 20 squared is equal to one leg X squared plus the other leg 16 squared. We're going to do the exponents. 20 squared is 400 equal x squared plus 16 squared is I just lost it. That's weird. 256. 216 squared. That was weird. That left me 256. Now we're going to undo. We have addition and exponent. You undo addition first by subtraction. So we get 144 equal x squared. We get rid of the square with the square root, and so we get x equal 12. Any questions on number 11? Number 12, we have a rectangle. The definition of a rectangle is it's a quadrilateral with 4 right angles, so that makes that a right angle. We know that in a rectangle, opposite sides are equal, so if it's 8 on top, it's 8 on bottom. If we focus on the bottom half of that rectangle, we have a right triangle in which we know 2 sides. So we can find this missing side using the Pythagorean theorem. It's opposite the right angle, so we identify it as our C. So we're going to use the formula C squared equal A squared plus B squared. And so we get our C, which is x squared, is equal to one leg 6 squared plus the other leg 8 squared. We're going to do the exponents to simplify. X squared equal 36 plus 64. Now we're going to do addition. We get x squared equal 100. We're going to get rid of the square with the square root, and we get x is equal to 10. Any questions on using the Pythagorean theorem? Okay. Now, we want to determine whether the following are triangles or not, and if they are, we want to determine whether they're acute, right, or obtuse. And to do so, we use the converse of the Pythagorean theorem. First of all, to be a triangle, the sum of the smaller two sides must be greater than the third. In other words, small 1 plus small 2 must be greater than large 3. Well, is the sum of the smaller two greater than the third? No, 3 is not greater than 3, so this is no triangle at all. Any questions on number 13? Number 14, we want to see if it's a triangle, so we check to see if the sum of the smaller two is greater than the third. Is the sum of the smaller two 5 greater than 4? Yes, so it is a triangle. Now that tells us it is one, but it doesn't tell us what kind. To see what kind, we compare the square of the larger to the sum of the squares of the other two. So we get 4 squared is 16, 2 squared is 4, 3 squared is 9, 16 is greater than 13. The larger side square came out bigger. If the larger is bigger, the angle opposite is bigger, so the angle is bigger than 90, so it's obtuse. Remember we talked about opening up the compass bigger. We stretched out the hypotenuse number, the bigger side, and so that's going to make the angle bigger than 90. Okay, number 15, we want to see if it's a triangle at all. To be a triangle, the sum of the smaller two sides has to be greater than the length of the third side. Is 7 greater than 5? Yes, so we know that it is a triangle. To see what kind, though, we compare the square of the longer to the sum of the squares of the shorter. If they come out equal, it's a right triangle because it satisfies the Pythagorean theorem. C squared equal A squared plus B squared. If it comes out bigger, then we stretched out that right angle and made it bigger, which created a right triangle. Number 16, to see if it's a triangle, we have to compare the sum of the smaller two to the larger. To be a triangle, the sum of the smaller two has to be greater than the larger. Is 9 greater than 6? Yes, so it is a triangle. To see what kind, we compare the square of the larger to the sum of the squares of the smaller two. 6 squared is 36, 4 squared is 16, 5 squared is 25, 16 plus 25 is 41. The square of the larger is less than the sum of the squares of the other two. That means my angle becomes smaller since the side opposite is smaller. And if it's smaller than a right angle, then it's an acute angle. And so we have an acute triangle. Okay? This is known as the converse of the Pythagorean theorem. Number 17, to see if it's a triangle, we make sure that the sum of the smaller two is greater than the larger. 11 is greater than 7, so yes, it is a triangle. And I'm going to move this out of the way just so I have a little more room. To see what kind, I'm going to compare the square of the larger with the sum of the squares of the smallers. 7 squared is 49, 5 squared is 25, 6 squared is 36, 36 and 25 is 61, 49 is less than 61. The larger side square is smaller, so the angle opposite is smaller than a right angle, If it's smaller than a right angle, it's an acute angle. So again, we have an acute triangle. Any questions on 11 through 17? The converse of the Pythagorean theorem. Okay. I'm going to stop there and record the second half on another video.